So today's topic is metal extraction, and as I told you that there are two extractions. One is extraction of zinc and another is extraction of iron. So first we will go for extraction of zinc. So if I want to extract a zinc, definitely I will require a ore, because from ore, it is the ore from which the metal is extracted. So the ore of zinc is zinc sulfide. Ore of zinc is zinc sulfide, ZnS. Step one for extracting the zinc from ZnS. So it is conversion of, step one is conversion of zinc sulfide to zinc oxide. So conversion of zinc sulfide to zinc oxide. So how it is done? You take ZnS, which is zinc sulfide at the start. You add oxygen to it. You get zinc oxide plus SO2 gas. And the balancing will be 2, 3, 2, 2. This balancing you can just remember 23, 22. Once I get zinc oxide, my step two is zinc oxide is reduced to zinc by carbon monoxide. So it is the reduction reaction which takes place. So it is ZnO plus carbon monoxide gives zinc plus carbon dioxide. So it's a redox reaction which takes place where zinc oxide is reduced to zinc and CO is oxidized to carbon dioxide. So we can say carbon monoxide over here it will act as reducing agent or oxidizing agent. Yes, Akbar, can you tell me? CO is getting oxidized to CO2. So will CO act as a reducing agent or oxidizing agent?
Oxidizing agent, right?
It will act as a reducing agent. So understand the concept of reducing and oxidizing agent. See, agent is the one who will itself gets oxidized, but it will do the work of other. Like let's say CO is acting as a reducing agent. So it is that agent which will reduce other substance, but itself gets oxidized. So the substance which itself undergoes oxidation will act as a reducing agent, and the substance which itself undergoes reduction will act as an oxidizing agent. So please copy down this. Step 1, step 2 for extraction of zinc, and that is how your zinc is extracted. Okay. Everybody will pay attention, very important process. Now, extraction of iron. So extraction of iron done from the ore of iron, which is hematite. The ore of iron is hematite, like how ore of zinc was zinc blende. Ore of iron is hematite, which is Fe2O3. Now, where is extraction of iron takes place? So it takes place in something called as blast furnace. So blast furnace is a place where your extraction of iron takes place. Now, how this blast furnace looks like? You are not supposed to learn the diagram, but I'm just giving you a kind of a skeletal structure, not exact structure, but just a small skeletal structure to understand that how is the blast furnace. So this is something like a blast furnace which is there, and why it is called as blast furnace, because over here the blast of hot air is going in. Okay, blast of hot air is going in, which is your oxygen. And there will be a very, very, very high temperature will be there. So this is like a blast furnace. Now there will be the raw material will be added to this. So this is a kind of a cone structure. In this, the raw material is going to add. So the raw material required, definitely the iron ore, which is Fe2O3, from which we need iron. There is also addition of carbon, but not carbon. The carbon is in the form of coke. So basically, it's not that soft drink Coca-Cola. It's a coke, means it's kind of a charcoal which is used. So over here, carbon in form of coke plus calcium carbonate is added. That is limestone. So total, how many raw materials? Three raw materials. Fe2O3, which is your ore, and two additional raw material as the carbon in form of coke and calcium carbonate, which is your limestone. Together, these three things is called as charge, CHARG. So these three things, when added together, it is called as charge. So all these three things are added into the blast furnace where the reactions are taking place. Now there will be series of reactions which are going to take place. So what happens in step one? So step one, now as I told you that blast of hot air will be given from below. Okay. So what happens? The carbon which is there, which is in form of coke, reacts with that hot air, oxygen, and it forms carbon dioxide. So carbon reacting with oxygen gives carbon, producing carbon dioxide, and this reaction is highly exothermic, as lot of heat energy is going to produce. So it's highly exothermic, and the temperature at which this takes place, it is 1400 degrees Celsius to 1500 degrees Celsius. So this reaction liberates lots and lots and lots of energy, and this takes place at a very high temperature, which is 1400 degrees Celsius to 1500 degrees Celsius. Now, once the carbon is reacted with oxygen to form carbon dioxide, and the coke which is present, that's the carbon which this is present, it is present in very large amount. So it is in excess. So what is my step two? My step two will be carbon dioxide will further react with coke. As I told you that coke is in excess, so there is more ample amount of coke which is present, that's carbon, and this carbon dioxide gets converted to reacts with carbon, and it forms carbon monoxide, So step one, we can say that it's an oxidation reaction because carbon is getting oxidized to carbon dioxide. Step two is carbon dioxide is getting reduced to carbon monoxide because one oxygen is lost. So it is getting reduced. And this temperature, this reaction takes place at a temperature about 800 to 900 degrees Celsius. Now, what is step three? Now, step three is very important. So, step three is this Fe2O3. Now, the hematite ore which is there. that is going to react with carbon monoxide. So whatever the carbon monoxide is present in step 2, that is going to react with Fe2O3, forming Fe plus CO2. So now tell me, in this reaction, who is undergoing reduction? Who is undergoing reduction? Fe2O3 is becoming Fe. So is that
So
undergoing
is Fe
reduction?
being reduced?
Yes, because there is loss of oxygen. So over here there is loss of oxygen. So this reaction is reduction. Who is undergoing oxidation?
CO.
Yes. CO, there is gain of oxygen. So it is oxidation. Balancing Fe2O3. So 2Fe and 4. So it will be 3 CO2, 3 to the 6 and 3 CO. Okay, now tell me, who is acting as a reducing agent in this reaction? Who is acting as a reducing agent?
Carbon monoxide.
Very good. So carbon monoxide will act as a reducing agent because it is because of carbon monoxide Fe2O3 is getting reduced. So this reaction is called as my redox reaction. Redox, where reduction and oxidation are taking place simultaneously. Redox reaction. Till here, everybody is clear what are the 3 steps. So once again, I'm explaining. You are doing an extraction of iron. So you need one starting material from which you are going to extract the iron, and that is Fe2O3. This extraction of iron takes place in the blast furnace. There are 3 things you have to add in the blast furnace: Fe2O3, carbon, and limestone. Step 1 is carbon getting oxidized to CO2. Step 2 is carbon dioxide is getting reduced to carbon monoxide. And step 3 is the redox reaction, where your Fe2O3 is going to react with that CO and it is going to reduce to Fe, and CO is getting oxidized to CO2. So till here we understood that yes, Fe2O3 is used so that we can extract iron, and carbon is used, or we can say carbon is the one which is going to help in reduction of Fe2O3. But till now, we have not yet studied that why calcium carbonate is added. What is the purpose of calcium carbonate? Because in all the 3 steps, the above 3 steps, there is nowhere mentioned of calcium carbonate. So why it is added? For what reason? So that the role of calcium carbonate comes from step 4. So till here, please copy this reaction and then we will go for step 4. So I'm giving you 3 minutes, 2 to 3 minutes. Please copy this. So what is the use of this calcium carbonate or limestone? So now this ore of iron which is there, which is hematite. Now every ore which is there, the ore is present in the earth's crust. So whenever you are digging out the ore, there will be some or the other kind of impurities which will be present in that ore. So ore of iron has impurities. Okay, ore of iron has impurities. And that impurity is nothing but it is SiO2, which is silicon 4 oxide, which is silicon 4 oxide. And that silicon 4 oxide is acidic in nature because it's a non-metallic oxide. So silicon 4 oxide, also called as silica. Now it is acidic in nature. So what happens in step 4 is Now I want to remove this impurity which is acidic. So what happens? This calcium carbonate, which is limestone, it undergoes thermal decomposition. So this triangle sign is actually heat sign, and it forms calcium oxide plus carbon dioxide, and it is thermal decomposition. Now this CaO, which is your calcium oxide, it's a metal oxide, and metallic oxides are basic in nature. Metallic oxides are basic in nature. So what is step 5? Step 5 is calcium oxide reacting with SiO2. So this is basic, this is acidic, and it is going to form CaSiO3, which is called as calcium silicate. And that calcium silicate is actually called as slag. And this reaction, base plus acid giving you actually a salt, this reaction is called as neutralization reaction. So step 4 and step 5, so this is actually the entry of calcium carbonate. So over here we understand that why the calcium carbonate was used to, because to remove the impurity. So this was the overall process of blast furnace, 5 reactions. You have to remember these reactions. Sometimes 5-mark question comes for extraction. That is, they can ask, explain the whole process of blast furnace. So you have to remember these 5 equations, not necessarily the temperature, the temperatures are fine, but what type of reaction it is. So that's why I'm going each of the reaction in detail. So neutralization, redox, thermal decomposition. So these reactions are very, very important. So please copy down this, and this is the overall extraction of blast furnace. So please copy down this. Now, once the iron is obtained from blast furnace, over here, let's say I have received the iron over here, which is my molten iron. Still, this iron is not that pure. It will still have some impurities. So iron which is obtained, iron obtained from blast furnace, okay, iron obtained from blast furnace, that iron is called as pig iron. The reason for the name pig iron, because it has still some impurities. So it still contains impurities like carbon and sand, that is silica, SiO2. Now what happens to this pig iron? What are these pig irons used further? So pig irons, sorry, they are basically soft ions. So they are converted into molds. Okay, they are converted into molds, and that iron is now called as cast iron. So now this, where are these cast iron used? So you know this drainage lids are there on the road, you can see. So the lids especially are made up of this cast iron because they do not require that much pure iron. So it's used on the roadsides. So that's why these pig irons, one of the thing is that they are converted into molds and they are being used in cast iron. Now, what is the peculiarity of cast iron? Now, cast iron is hard but brittle. So cast iron is hard but brittle. Why it is brittle? Because of carbon content. More the carbon content, more the iron will be brittle. But what is the main use of iron? Can anybody tell me what is the main use of iron? Where is iron mainly used? Yes, can anybody tell me where is iron? Main purpose of use of iron is steel making. 80 to 95. So yeah, alloy. So alloys is steel is an alloy. That's correct, Akbar. So the alloy of iron is steel. So majority of your iron which is being extracted is being converted into steel because it's the steel which is being used in different products. You are not using directly an iron because as I told you that pure iron is not that hard. It can be brittle also. So and to enhance the strength, there is alloys, that is alloys of iron, which is steel. Now steel are of different types depending on what is the use. Like we have stainless steel, we have mild steel, we have machinery steel, we have dockyard steel, different kinds of steel. We are going to study about two types of steel, that is one is mild steel and one is stainless steel. So just take a screenshot of this, everybody, so that I can go to make you understand that what is steel making process, because that is also important. So the main use of iron is steel making. So let's understand how this steel is made. The steel making, which is an alloy of iron. Now the pure iron which is there, the pure iron is very soft. Pure iron is very soft and it gets corroded. It gets corroded very easily. Okay, it gets corroded very easily. So what happens is, if we add small amount of carbon, if we add small amount of carbon plus pure iron, you will get something which is called as mild steel. Okay, and where is this mild steel used? Now mild steel it is hard and strong. Okay, mild steel is hard and strong and it is used for building ships, car bodies and machinery. For building ships, car bodies and machinery. Okay, so ships, car bodies and machinery. But to iron, okay, so this is one part, part two. But if I have iron, to that if I'm adding carbon, then I'm also adding nickel and I'm also adding chromium. By adding nickel and chromium as well, this gives me something called as stainless steel. Okay, this gives me something which is called as stainless steel. Now, stainless steel is having an altogether different property, which is hard and rust proof. Okay, it is hard and rust proof. And what is the use? Where do you use stainless steel?
This in like pots and pans, utensils.
Yes, so basically kitchen utensils and also in surgical instruments. See, there is always a demand for such kind of product which should have a rust proof, because if we are eating, we cannot afford to have like to eat with a spoon which is rusted or to use a knife which has rust. So we should have a very good quality of steel. So stainless steels are such steel which will not rust. Even the surgical instruments, like if the operations are done in the hospitals, you require certain instruments, which is knife, scissor, like so many other needles, like for vaccination. You cannot have something which is a very, very, you can say, a cheap type of a steel which can get corroded easily. So you require stainless steel. Okay. So whatever steels you get it in supermarket, or even if it is said stainless steel, that's not necessarily that it is 100% stainless steel. Okay, it has a different altogether quality. If it starts getting corroded, it is not stainless steel. Okay, if it is not stainless steel, it can be a mild steel, because the car bodies, the ships, the machineries, like let's say about the ship, the ships which are there, or the car bodies which are there. So they are being then, they are being electroplated. But the especially if we talk about this big cruise and the ship, why they are so heavy? Because they are made up of steel. And since they are always in the water, salt water especially, so salt water is the one which will enhance the rusting. So that's why there is something which is called as galvanization, which is done for preventing the iron to get rusted. So these are two types of steel. One is mild steel and one is stainless steel. Now, how this stainless steel is produced? We understood what are the types of steel, but how this steel making process is done. So please take a screenshot quickly for this. So how this steel making process is done. Everybody took the screenshot? Yes? Okay. Let's go ahead for steel making process. So steel making process, now whatever the molten iron which we obtained from the blast furnace, molten iron from blast furnace is transferred to something called as oxygen furnace. Blast furnace to oxygen furnace. Now what happens in this? As I told you that molten steel from blast furnace still contains some impurities like carbon and sand. So I need to remove that impurities. So if it is being transferred to oxygen furnace, so what is step 1 done over here? O2 will react with carbon and it forms either carbon monoxide or carbon dioxide. Okay, in fact, not or, it's and. Both of them are being produced. Also, O2 reacts with other impurities, like sulfur and phosphorus. Okay, other impurities like sulfur and phosphorus, and converts them into respective oxides like SO2 and P2O5. So S, like sulfur impurities, gets converted to sulfur dioxide and P2O5. And then last thing, what is done? Quicklime, which is calcium oxide, is added. Why? Because calcium oxide is a basic oxide. Okay. Why it is added? So to remove the acidic impurities, which is SO2, P2O5, and SiO. Okay. And this is how your steel is made. So basically, finally, the iron which is there, that's been added to carbon, depending on the requirement. nickel chromium, and that is how the steel making process. So this is the pre-step of steel making process. Okay, please copy down this. Don't take screenshot, copy down this. Let us understand something which is called as metal reactivity series. A metal reactivity series, we have potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, Fe, Pb, hydrogen, copper, mercury, silver, gold, and platinum. Now, if you look at this reactivity series, now you will understand that, see, we have already done extraction of aluminium. How was extraction of aluminium done? Our first topic. What was our first topic? Aluminium was extracted from Al2O3, aluminium oxide. By which process? What was our first topic we did?
Electrolysis.
Yes, so aluminium was extracted from Al2O3 by electrolysis. Now today we learned zinc, today we learned iron. In both of them, we used carbon monoxide as a reducing agent. Means somewhere, so carbon, so we are using carbon. So can you see this extra, the reactivity series, that why carbon is used? Because carbon is more reactive. So this is the reason carbon is on the top. Carbon is more reactive than zinc and Fe, and that is the reason you can use carbon as a reducing agent. So all these metals, if I want to extract from its ore, I can very well use carbon. But for aluminium, I cannot use carbon. I cannot use carbon. Why? Because it is less reactive. Okay, because it is less reactive. Now talking about thermite process. Okay. So application of reactivity series, thermite process. Now you know this railway tracks. Now this railway tracks are made up of iron. And this railway tracks gets oxidized because they are always opened or they are always exposed to the environment, to the atmosphere. Now, if let's say a part of that railway track gets corroded, gets rust, what happens? Do you just lift up the whole track and you replace the track? Do they do that? I mean, is that the process? Yes, railway tracks are always exposed to the atmosphere. So what do they do? So what they do is, see, railway tracks are made up of iron, and Fe gets rust. Okay, so basically Fe gets rusted. So what is the formula of rust? It is Fe2O3.3H2O. So it is basically hydrated iron 3 oxide. Now I want to remove this rust. I want to replace this rust. So what happens is, this Fe2O3 is reacted with aluminium. So there is something called, there is a machine which is there where the aluminium is heated. And can you see this reactivity series? Can I say that aluminium is more reactive? So aluminium is going to react with or displace Fe, and it is going to form aluminium oxide plus Fe, which is in the molten form. So this molten Fe, now if the iron melts, what is the basic thing about about the melting? Can I say whenever a thing gets melted, it expands?
Yeah.
Correct. So if that molten iron gets expands, because of that expansion, the crack which is there. See, when the iron gets rusted now, what happens? There is a crack on the railway tracks. Now the crack needs to be filled up. The gap needs to be filled up. So what happens? They take some machine which has an aluminum. They just what you can say, they put that aluminum on that part where the track is rusted. Because of the displacement reaction, the aluminum is also in the molten form. The aluminum displaces the iron, and because of which the iron which is there, it gets melted. You can see the reaction. You are getting a free iron, but it is in the melted form, and this molten iron will fill the gap, or we can say fill the crack gaps. And this is an exothermic reaction because lot of heat energy is given out. Okay, lot of heat energy is given out. You can also watch a video that how the crack of the railway tracks are being filled up. So this is the reaction which is taken. This is called as thermite reaction. And the last part, please not copy, just take the screenshot, and we'll do the last part, which will be the end of metal extraction. That is the second application of reactivity series. Okay, so let's go to the next one, second one. The second application of reactivity series is called as sacrificial protection. Sacrificial protection of zinc. Of iron. Iron is a very important metal, so we need to protect it. So iron gets rusted. So for protection, zinc is coated to iron, and that is called as galvanization. Okay, that's called as galvanization. So suppose, let's say if this is my iron nail, I want to prevent it from rusting. So I will coat this with the help of zinc. Now, how it will prevent rusting? Because if you look at the reactivity series, again, zinc is more reactive than iron. So zinc is more reactive than iron. So it is the zinc who will readily lose electrons than iron. So if there is zinc and there is iron, it is the zinc who will come forward and it will lose its electron. Means it will be the zinc who will oxidize. It will act as a protecting barrier for the iron, so that iron will be protected. So zinc will be oxidized to Zn2 plus, and the reaction will be Zn, 2 electrons lost, becoming Zn2 plus. So this is how it is called as sacrificial protection. Why sacrificial? Zinc is sacrificing its electrons to protect the ion. So that's why it is called as sacrificial protection. And this is the end of the topic, metal extraction. So we finished over here 3 topics: electrolysis, hydrocarbons, and metal extraction. When we meet in the next class, that is next week, we are going to do acids, bases, and salts. So we are going to touch few important concepts of acids, bases, and salts. Okay, so that is what our next week agenda is. So with this, we'll end the session for today. Thank you very much and wishing you a very happy week, and see you guys on Sunday at 12:30. Till then, bye bye. Take care.
Thank you, miss. Bye.
Bye bye.
Bye, miss. Thank you.
Bye. Take care.